My name is Greg Smith, and I run product and technical marketing at Nutanix. So it's our privilege to be here today. I appreciate everyone attending. I think some of you were here or joined us in San Jose for the Tech Field Day last year. So for those of you that are returning, thank you. For those of you who are new, also thank you for attending. And we're going to make sure that we give everybody a good overview of what Nutanix does, our solution and technology, and make sure everyone has a clear understanding of how we're able to bring greater storage efficiencies to enterprise data centers. So I'm going to spend 20 minutes and give you a brief introduction to the company and our product and some of the technology, and then my colleagues will follow me and we'll go deeper into how Nutanix, again, provides storage as a service to enterprise data centers. So like most companies, there's a founding premise, and our founding premise was that storage was broken in enterprise data centers, that it was too expensive, it was too rigid, and it didn't scale. And in short, that the storage infrastructure had not kept up with the rest of the data center. And this was particularly true as we started to virtualize workloads in the server tier, that our customers saw performance issues, bottlenecks, typically in the storage backend. So what we have done is what has been done in many of the cloud providers and web scale firms is we actually brought storage, data storage closer to the compute tier via converged architecture. So let me tell you a little bit about Nutanix. So the company was founded in 2009, and we started shipping product in late 2011. So we've been shipping product for just about a little more than a year and a half. The company is privately held. We are funded by top-tier venture capitalists. You see Coastal Ventures, Lightspeed, Goldman, and Battery. And we have grown at a pretty rapid rate. So we're here in June 2013. We count 215 employees worldwide for the company, and that's across our San Jose headquarters as well as sales offices around the world. Very prudent business plan. So of the $72 million we've raised, over about 50% of it is still available to us in the bank. And that's also made possible by a very rapid revenue growth too. So very sound business fundamentals. The team hails from a number of leading companies. So a lot of the founders come from Google and Facebook. And as we talk about some of the technologies, you'll see why that makes sense and why that allowed us to develop a really strong architecture that allows us to scale the storage infrastructure. But what we've done is we've taken the understanding of what is powering Google and Facebook and combine that with leaders from enterprise companies. So you see some of them represented today. So this is Cisco, Palo Alto, Citrix, EMC. So you have this unique blend from both the technical and the business team at Nutanix, where we're able to fuse some of the very massive scale architectures that power some of the largest cloud environments, along with experts from the enterprise space. And so we're able to bring those technologies and make them consumable for enterprise data centers. From a product perspective, we've been selling, as I said, for about a year and a half, and the product's been well received in two regards. One is phenomenal revenue growth, which I'll touch on in a bit, but also in the community, you see that we've won Best of VMworld 2 years in a row, and then just last year, Best of Interop in Tokyo. So very proud of the reception the product has had in the marketplace. The 5 things I'd like you to keep in mind, not just through my presentation, but through the balance of our time here, are the 5, we call them virtues or tenets, that upon which Nutanix Virtual Computing Platform is built. And these are things that the founders, the technical founders, embodied in the product from day one, and they provide that guidepost for our entire roadmap. And so one is scale out. So there's no more important aspect to our product than the ability to scale out. That's horizontal scale out on a per node basis. We think that's the only way that one can achieve economic and efficient scale from a storage perspective, is if I have a shared nothing scale-out architecture that allows me to build one appliance or one node at a time, unbounded. And we'll talk about some of the technologies that enable that. Fundamentally, we're a converged infrastructure solution. So we have taken the server tier and the compute tier and merged into a single platform. It allows us to get very good storage performance, remove some of the inefficiencies and the complexities that are inherent with the storage network, and frankly, it puts data where it belongs, closer to the workloads with the compute tier. It is these types of converged architectures that are powering some of the largest websites and clouds today. And what we've seen historically is a lot of the innovations that take place with in the cloud infrastructure and the web scale and the very large web properties. Traditionally, those technologies, those architectures, ultimately find their way into mainstream enterprises. We think this is a classic example of that. Also, we're very strong proponents of software-defining services in a data center. So we believe that to maintain that agility, that all services, storage included, must be delivered as a software service. And they must run independent of the hardware. That we like to talk about that our storage service and our converged infrastructure is completely software-defined. That everything is late binding, it is not hard-coded into hardware, into proprietary ASICs or FPGAs. That allows us high feature velocity to bring new capabilities to market. We ship on commodity hardware, but our IP and all the intelligence is driven by software. We incorporate large amounts of flash. We've seen flash to revolutionize the storage industry. Our approach and our firm belief is that flash belongs on the server side. Again, bringing storage closer to the compute. It's only when I put flash on the server side that I'm able to get full utilization of the solid state technology. We also believe that this converged infrastructure has to live in a hybrid environment, in that today's enterprise data centers, today and going forward, will be a combination of both private clouds, either on-prem or off-prem, combined with public cloud resources. And so our architecture is intended and is designed to be extensible so that we can support both on-prem as well as cloud-based storage and cloud environments. So I indicated that Nutanix's architecture was inspired by some of the larger cloud providers, specifically Google and Facebook. So what I mean by that is, I'll use Google as the best example. When Google had to build out a data center, they had to plan for massive scale. And what they concluded was that the traditional approach of having centralized storage on the back end, whether it be a NAS or SAN, simply would not work for them. That they had just massive requirements on storage performance, and scale out. And to give you one example of this, that in just about a year and a half ago, Facebook, just to give you a sense of the actual data storage requirements, in Facebook, they are maintaining online 7 petabytes of data that's continuously accessible by users as well as Facebook admins and data scientists. 7 petabytes. They're bringing online 500 terabytes every month. So clearly, they needed a new approach. What they were able to do was eliminate that storage tier and converge it with the compute tier. And they did it using x86 technology. So again, they're running everything on commodity, inexpensive x86 hardware, thousands, tens of thousands of nodes distributed through the data center. And they rely on the software and the intelligence of the software to provide the scale-out capabilities as well as the reliability. So this is what the largest cloud and web scale companies are doing. They're relying on software-driven intelligence, making everything a service, converging compute and storage, and running everything on commodity hardware. And that's the same philosophy the same architecture, the same approach that Nutanix brings. Just so happens that this aligns very well with the direction that a lot of enterprises are taking, and this was articulated by Paul Maritz just last year, when of course he sort of declared the beginning of the era of the software-defined data center. And there's a great alignment between what we've seen in the Googles and the Facebooks and where the enterprises are going, in that the data centers are becoming much flatter. So I'm able to scale horizontally and move away from a monolithic approach that forces me to scale increasingly up with more expensive proprietary hardware. And everything is run on x86. Everything is delivered as a service. We've seen this in other parts of the data center. Services, functions that have historically been delivered on proprietary appliances are now being virtualized. They're being virtualized and they're being run in the same infrastructure. So whether it be networking, security, or storage, it's all becoming a service that can be provisioned on demand anywhere in the data center, and that allows me to scale out at high performance. So very simply, this is what Nutanix does, right? We've adopted the same architectures, and we've taken what you see here is in a traditional architecture where I have a virtualized server tier connected to a backend storage, and this could be SAN or NAS with a storage network. And what we've effectively done is we removed the necessity for that storage network, and we've converged the compute and storage into a single appliance. In that appliance, we run independent nodes. So each node has direct attached storage, both flash and hard disk drives. All nodes in the cluster are connected by standard Ethernet fabric, 10 gig or 1 gig. And what we're able to do is scale from anywhere from 4 nodes to hundreds of nodes. And the performance is completely linear. And that's driven by the software that allows us to scale out. So what we've done each node is with the flash and the hard disk drives is it's direct attached in the node, but we're able to aggregate it across all nodes in the cluster and present it as a single one or more data stores to the host. So we get the benefit of all the aggregate storage from every node in the cluster that can now service every guest and every host. We also run the flash and the hard disk drives as separate tiers. So we're able, along with our advanced information lifecycle management ILM, is to be able to put frequently accessed data in the hot tier, in flash for the highest performance, and then down migrate more cold data into more economical hard disk drive. So we're able to aggregate all the flash and all the hard disk drives into 2 persistent tiers of data. Those storage resources are managed by a virtual controller. And that virtual controller runs as a VM, and it runs on every node. So I have local storage control logic on every node. So it allows me to do a number of things. One is that it allows me to manage the data between the tiers. It allows me that when a guest or a host wants to write data, it can write locally and managed by that controller. It also allows me, because I have one storage controller for every node, that when I add nodes to the cluster, I not only scale out my capacity, I not only scale out my compute, but also my controller logic. So I'm no longer bound by a finite number of controllers, and I can scale my storage performance, my IOPS, as I build out the cluster with more nodes. So Nutanix sells appliances. We call it the virtual computing platform. But the real IP of the company, and what we'll be talking about throughout today, is really in the software. And we call this the Nutanix distributed file system. And what it allows us to do is run this distributed file system across all the nodes in the cluster. Everything is a shared nothing. So we're able to manage data, metadata, configuration data across all nodes so that we can scale perfectly linearly across there. And we can also be resilient in terms of node failures in all respects. We built it to be hypervisor agnostic. So most of our customers today are using Nutanix Virtual Computing Platform to run ESXi workloads. But we also support KVM, and you'll see later on today that we will support other hypervisors as well. So the architecture is built to be hypervisor agnostic. We think that's very important from an enterprise perspective because a lot of customers, a lot of data centers need to run mixed workloads. So that will be an enterprise requirement. So what we're able to do is, as I said, take all that storage and present it as a single data store to all of the hosts. So the goal is to make storage an invisible service, to make storage invisible, so that once I configure this cluster with compute and storage, I do it one time, I configure my data stores, there's no concept of ones or RAID groups, and then I can sort of set it aside and I can use vCenter or whatever orchestration or virtualization logic I want to provision workloads without having to worry about back-end storage resources. And of course, because we've converged enterprise storage, we provide all the storage capabilities that people need. This is replications, snapshots, clones, and such. So this is a virtual computing platform. That is Nutanix's description of what it means to provide converged compute and storage in a single appliance that can run any VM. And you see some of them here. So we have hundreds of customers today running virtual desktops, core enterprise workloads. People are starting to migrate databases, virtual machines, whether it be load balancers, ADCs. So increasingly, people are migrating a wider variety of VMs onto these platforms. One of the most important benefits of converging compute and storage and making it available in a single node or single appliance is it allows me to more precisely match my environment to the needs. So I don't have to over-provision. So if I start with a POC, if I have a small evaluation environment for a new app, a new workload, then I can start with a single 2U footprint with 4 nodes and to match that workload. Now, when I scale out, I can simply add additional nodes, additional appliances as I need additional scale. So again, I don't have to over-provision. I can start small, and then I can pay as you grow. So the approach is sort of bite-size, that I'm not having to provision massive amounts of storage initially or massive amounts of compute. In terms of our market success, just some of the customers that we have, we are focused very, very strongly on core enterprise workloads. Everything you'll see in the product and the architecture is really intended to run a wide variety of VMs in both medium-sized and very large enterprises. In terms of the portfolio, and we'll be talking about the roadmap both on the hardware side and on the software side in a bit, but we made an announcement just this week where we've expanded our portfolio. So our flagship products have been the 2000 and 3000. These have been very, very successful for us. We're running a wide variety of workloads, provides a great balance between storage and compute. What has happened is that we have been pulled into different parts of the enterprise and been asked to support a wider variety of workloads. And as a result is just this week we announced 2 new platforms, the 1000 and the 6000. So what we've done is we have provided a greater range of storage and compute resources in that balance, so that if someone needed less compute and less storage for, say, a branch office or a smaller size organization, we can meet that need. We also have provided the 6000, where we've tripled the amount of storage. We've kept a fairly even level of compute, but for very storage-intensive, data-intensive applications, we now provide a converged infrastructure that can support those as well. And of course, the software allows us to mix and match across the environment. So I can have a combination of Nutanix nodes in a single cluster. So it allows me to in a fine-grained way, balance the infrastructure with the specific needs of the applications I'm running the infrastructure. So if I have data-intensive apps, I can provide a storage-heavy virtual computing platform, and I can mix it with others. So it gives you a lot of flexibility of how I do this. So again, what we're doing is we're providing a portfolio of, we call them virtual computing platforms or appliances, independent nodes connected via Ethernet fabric. Each node converges compute and storage. We maintain the data storage in both flash and hard disk drives and present it as a common shared resource to all of the guests. So we believe that this is the right way. This is the future for enterprise data centers. It's a very effective, very economical way of making storage almost an invisible resource for all virtual workloads. From a company perspective, we, as I mentioned, we started delivering product in November of 2011. Since that time, we've grown astronomically. In fact, we believe that we are the fastest growing infrastructure company of the last decade. And after only 6 quarters of shipping product, we have hit a revenue run rate of $80 million a year, which we think is unprecedented in this space. So that is proof that this approach, this technology is needed in the environment. We have decided as a company to meet this demand by building out a worldwide sales team and channel. So we made the strategic decision to go globally rather than work diligently over time to prove it out in a single market. We think that the need for converged infrastructure is a global phenomenon. It has applicability everywhere. So Nutanix, our investors, our board, our management team has been very aggressive in terms of building out the go-to-market resources so that we can deliver to all parts of the world. So we have over 25 sales teams throughout the world, and we have over 200 channel partners now on board with Nutanix being trained and selling.